Good morning, students. Today I will be finishing theoretical problems in Pythagoras theorem. Let us finish up soon. PQRS is a quadrilateral. This is for 10 state Cbse, Icse, Pythagoras theorem theoretical problems. PQRS is a quadrilateral in which diagonals PR and SQ intersect at right angles. These are all the different models I am doing. So many problems are covered from different textbook. Only few problems are left over. Those are only 3. So with this, all problems are covered from all the textbook. PQRS is a quadrilateral in which diagonals PR and SQ intersect at right angles. Prove that PQRS is a quadrilateral in which diagonals PR and SQ intersect at right angles. Right? Prove that PQ square minus PS square is equal to QR square minus SR square. So this is another different problem, I can say. So let the diagonals intersect at O. Let diagonals intersect at O, right? So PQRS is a quadrilateral. We don't know what type of quadrilateral, but we know that diagonals intersect. Diagonals are what they give. PQRS in which diagonals PQ and diagonals intersect at right angles. Prove that they are asking this one. So diagonals intersect at right angles. Prove that they are asking PQ square minus PA square is equal to QR square minus SR square. How to do this one is very simple. PQ square. Apply Pythagoras theorem for this triangle POQ. Square on the hypotenuse is equal to, since this is the final session, I am writing direct steps. PQ square is equal to what? OP square plus OQ square. Right? Next, this is over. See, keep in mind what we have to prove also. PS square. PS is this one, right? PS square, square on the hypotenuse is equal to OP square minus OS square, right? So what we have to do, addition or subtraction? Subtraction. Already I told we have to keep in mind what we have to prove. Then only you have to write the steps. So here subtracting 1 and 2. Subtract. So PQ square minus PA square is equal to OP square gets cancelled. OQ square minus, sorry, it is plus no, OP square plus OS square. So OQ square minus OS square. Please pardon me, this is square on the hypotenuse is equal to sum of squares on the other two sides. Next, OQ square minus OS square. OQ, where is OQ? OQ. See what you have to prove? OQ square. This OQ square, how will you get? Just I am asking OQ. This is the right angle triangle. OQ square, how will you get this one? By subtracting square on the hypotenuse minus the other side. So that means OQ square, how will you get is QR square minus OR square. We'll get this OQ square. OQ square, just concentrate this triangle. I am saying that this square on the hypotenuse, how will you get? By OQ square, how will you get? By subtracting square on the hypotenuse minus this side. So QR square minus OR square. In the same way, minus is outside. OS square, how will you get this OS square? For this triangle, how will you get this OS square? By subtracting the longest square on the hypotenuse, SR square minus OR square. Right? SR square minus OR square. This square minus this square. Or else, still if you are not understanding this, what I am speaking, we will go for this. QR square is equal to OR square plus OQ square. We want what? QR square. We want here OQ square. So OP square write as this QR square minus OR square. See here, QR square minus OR. So this is another way of understanding. But my logic is, when you don't know OA square, take this one. OA square how will you get? By subtracting this minus this. Next, QR square minus OR square minus SR square minus this plus OR square. Plus OR square minus OR square will get cancelled. So what you will get? QR square minus SR square. See here, QR square minus N. I took LHS, I got RHS. There is the problem. Next one. Is it clear this problem? Just apply Pythagoras theorem. There ends the solution. Next one. ABCD is a quadrilateral in which angle A is equal to angle D is equal to 90 degrees. Angle A and angle D is equal to 90 degrees. ABCD is a quadrilateral in which angle A and angle D. Angle A is 90, angle D is 90. Prove that 2A square minus, so not 2A square, prove that AC square plus BD square minus AD square is equal to AB square plus CD square plus AD square. So this is what we have to prove. This is another different model. So AC square plus BD square, something they give, minus AD square, AB square plus BC square plus AD square. Once again, let me check the question. AC square plus BD square minus AD square, right, is equal to AB square plus DC square plus AD square. Question is correct. So ABC is a quadrilateral in which angle A and angle D 90 degrees. So for this, what you have to do is join this one. So this becomes a right angle. This is the hypotenuse, right? Square on the hypotenuse. Since we are in the end of the session, I am writing directly. Square on the hypotenuse. BD square is equal to AD square plus AB square, right? Square on the hypotenuse. For this, consider triangle DAB. This angle is 90 degrees. So this becomes the hypotenuse. BD square is equal to AD square plus AB square, right? Next, go for this. Consider triangle ADC now. Consider triangle ADC. This is triangle A. Consider triangle ADC. Square on the hypotenuse is equal to what? Square on the hypotenuse is equal to sum of squares on the other two sides. AD square plus CD square, right? Now, what you do is add these two conditions. BD square plus AC square is there, no? Add it. BD square plus, adding 1 and 2. BD square plus AC square is equal to what you will get? AD square plus AB square plus AD square plus CD square, right? So BD square plus AC square minus, bring one AD square to this side, minus AD square is equal to, this remains same, AB square plus AD square, this also remains same, plus AB square plus AD square plus CD square. See here, AB square plus AD square plus CD square is equal to BD square plus AD square minus AD square. this one is equal to this one. Very, very simple. Nothing is there. Consider this triangle. Only thing is, before doing this, you should join, write the step, join BD, and here consider triangle DAB we have written now. For this construction, before doing the problem, what I am saying is join BD and AC. First step, the very first step is join BD and AC. Then consider triangle this one, consider triangle this one. Add that. Very simple. You will get. I added these two. Here AD square is written twice. So one AD square bring here. The rest of the things keep as it is. This one, AB square, AD square, CD square. Keep as it is. Only bring this term this. That's it. There ends the problem. Once again, ABCD is a quadrilateral. Angle A and angle D 90 degrees given. So therefore, you need to join BD and AC. Then apply this Pythagoras theorem for this triangle. Consider this triangle. Apply Pythagoras theorem for this. Then BD AC remain same. Bring this to this side. Then AB here, AD here, CD here. That's it. Very simple. Next. ABCD is a square. This is another difficult and different problem. ABCD is a square. ABCD is a square. P is a point on BC. P is a point on BC. AECF and AECF are perpendiculars on DP. DP, join DP. AE and CF and AE. CF and AE are perpendiculars to DP. Prove that DE is equal to CF. So ABCD is a square. This is the last problem of Pythagoras theorem. So many problems I have solved. So I am ending with this problem. This is for 10th state, Cbse and Icse, and 9th class Icse. This is for 9th Icse textbook. They have Pythagoras theorem, numerical as well as theoretical problems. Numerical problems are very easy. Please try by yourself. I am doing theoretical problems. Numerical problems also I have done. Please go through it. There are several videos regarding this. Let us finish off this chapter. So before doing this, area properties of a square you should know. In a square all sides are equal. Only that thing is required in this. And one more, the usual routine. Usual routine means you have to prove that the triangles are congruent. There ends the problem. And as well as you have to apply Pythagoras theorem also. So consider triangle. And one more thing I would like to ask. If one angle is 90 degrees in a triangle, what can you say about the other two angles? When you add the sum of the other two angles, the result should be 90. So if this is 90, mark this as A, mark this as B. Angle A plus angle B is how much? One angle is already 90. Sum of three angles of a triangle 180. So angle A plus angle B is 90. Right? So here angle F is 90. I am sorry. Here in this triangle, if this is 90, obviously this will be 90. So if this is 90 means obviously this angle plus this angle is equal to 90. Sum of three angles of triangle 180 is 90, x plus y is 90. So therefore, what you have to do is consider triangle ADE, and ADE you should consider, and triangle DCF and triangle DCF. CF, right? So I will draw the sub diagram. This is very important. This is 90, right? A, E, D, and this one, another one. This is F, C, D. So here and A, D, E. This is the sub diagram. If you understand this, the problem becomes very easy. Already I told. So this is 90, 90. DFC is 90 and DEA 90. In these two triangles, angle CFA, CFD is equal to DEA. DEA both are equal to 90 degrees. Why? Because what? Because AE is perpendicular to DP and CF is perpendicular to DP, right? AE is perpendicular to DP and CF is perpendicular to DP, right? Therefore, this angle 90-90 is over. Now, this D and this what is given? So ADF, this is A, right? Next angle, this is DEA, DEA or DAE, DAE is B, correct? Look at this sub diagram carefully. This angle is 90. CDF is this angle is X. Next DFC is over. DCF is Y. So here AD is equal to CD. Do you agree with me? AD is equal to CD. Why? Can anyone tell me why AD is equal to CD? Yes, it is a sides of the square are equal. In a square, all sides are equal. This condition is over. Next, AD is equal to CD. That means AD is equal to CD. Right? Next, this is over. Right angle is over. Hypotenuse is over. I want to prove these two triangles are congruent. Next, what can you say? One more is left or no? Can you prove any other way? Why this angle 90 degrees? What is it? Angle B is 9. This angle is 90. So one more thing, AD is equal to CD since sides of a square are sides of a square in bracket. Next, what can you say about this angle? Just I am asking this angle. Angle D in a square, each angle is 90, no? So obviously, therefore, angle D is equal to 90. Why? Angle D is 90. Why? Because in a square each angle is 90. Therefore, angle A plus angle X is equal to 90. Right? Angle A plus angle X is equal to 90. Are you following? Angle A plus angle X. This angle, when you add these two, the result is 90. Now, this up until here, any doubts? This 90 degrees. So AD is equal to CD over. Now, in order to prove that these two triangles are congruent, I am doing all these manipulations. So angle A plus angle X 90. Here, already I said one angle is 90 means angle A plus angle B 90. Angle A plus angle B is equal to 90. Right? Here one angle is already 90. That means angle X plus angle Y 90. Right? So therefore you can equate these two, right? Angle A plus angle B is equal to angle X plus angle Y. That is equal to 1, 2, 3. Angle A plus angle B 90. Why? Because one angle is 90, the other two. Angle X plus angle Y 90, because one angle is 90. And therefore angle A plus angle X 90. So from this, just take these two conditions. Angle X plus angle Y is equal to angle A plus angle X. These two, equate these two. Angle X plus angle Y is equal to angle A plus angle X. Angle X cancel. Angle A is equal to angle Y. Right? Angle A is equal to angle Y. Angle A is equal to angle Y. Next. And also you can equate these two. You can equate these two also. I am writing here. Next, angle A plus angle B is equal to angle A plus angle X. Angle A cancel, angle B is equal to angle X. So angle B is equal to angle X, angle A is equal to angle Y. 1, 2, 3, 4, 5. Angle A is equal to angle Y. So therefore angle A is equal to angle Y. We have proved that angle A is equal to angle Y, angle B is equal to angle X. Just I am erasing all this. Here what we can say, angle A is equal to angle Y. That means use three letters. Angle A is equal to angle Y. Next, angle B, angle X. Angle B, angle X. Use three letters. Angle A is what? ADE. Angle ADE. Angle A is equal to angle Y. Y is what? DCF. DCF. Next, use three letters. Angle A is equal to angle Y. This over. Angle B is equal to angle X. Angle B is nothing but DAE is equal to DAE is equal to angle X. Angle FDC. Right? So therefore what? The triangles are, already we have proved that this angle is 90 degrees. Triangles are how this angle is equal to this angle, and ADE is equal to DCF. Next, DAE is equal to FDC. DAE is equal to FDC. And again, AD is equal to CD. AD is equal to CD. Therefore, by which property the triangles are congruent? By angle side angle. Angle side angle. Why? Because this is the common side. AD is equal to CD. This is the common side. So angle A later is coinciding with which one? Angle A is coinciding with angle Y. See here. Next, angle B later is coinciding with angle X. Therefore, triangle DAE is congruent to triangle, which triangle? Letter D. This A should coincide with which one? Y. That means C. Letter A should coincide with DAE. B should coincide with X. That means CDF. Angle, side, angle. I don't know. I want to prove that these two triangles are congruent. What I am saying is, I have proved that this angle is equal to this angle by some manipulations. Now I am saying that I want to consider this triangle. I have written using 3 letters format. You can go through it. ADE, DCE. ADE, ADE, that is angle A is equal to angle Y. Next, angle DAE. DAE, angle B is equal to angle X. Angle B is equal to angle X. Therefore, by angle side angle, the triangles are congruent. Therefore, the triangles are congruent means what? What we have to prove? Therefore, the triangles are congruent. Leave it like this. See, the letters are coinciding. AD, CD, yes. Angle D and angle C. Use the 3 letters format. Already I have proved. 3 letter format. Consider now. So therefore, what you can say? AE is equal to first letter is equal to DF. Therefore, AE is equal to DF. AE, this part is equal to this one. Right? Apply Pythagoras theorem. This is very, very difficult and lengthy question. Apply Pythagoras theorem. Square on the hypotenuse. AD square is this one. Triangle DAE. Square on the hypotenuse is equal to sum of squares on the other two sides. AD square is equal to DE square plus EA square. Next, apply Pythagoras theorem for it. CD square is equal to DF square plus CF square. So AD and CD are same since the sides of the square are equal. So therefore, DE square plus EA square is equal to DF square plus CF square. But AE is equal to DF. AE is equal to this one is equal to DF. Since see here, AE square is equal to DF square. Therefore, DE is equal to CF. DE square is equal to CF. That implies DE is equal to CF. Therefore, DE is equal to CF. That only we have to prove. DE is equal to CF. Hence the theorem. So it's very lengthy. Nothing is there. Just prove that these two triangles are congruency by angle side angle property. And this, what is it? This side is equal to this side. You prove it. Therefore, apply Pythagoras theorem for this triangle. Since AD is, why you have to equate these two means since sides of square are equal. Therefore, I have equated these two. But A is equal to DF already proved. Therefore, DE square is equal to CF square. And there is the problem. This is a typical problem. So with this final session, Pythagoras theorem completed. Please subscribe my channel. Click on the blue color icon button and share these videos with your friends so that they will also get knowledge and they will improve further. Let us expand the channel. Thank you. Have a nice day. Bye.